Well, Mr. Sam, this is the last podcast.
Yeah.
Man, 9 podcasts on bonding.
Yeah, they've been nice and short.
Yeah, they've been good, I think. So, hey, bonding, we want to summarize this. This is really important. It's kind of the question, which one has stronger bonds?
Yep.
To understand this, the key thing is this
The chart.
The chart. And we've already talked about this, but I want to...
Let's do it again.
Yeah, print this if you haven't already done so. All right, or copy it down. Now, let me talk about the numbers for a minute.
Okay.
Okay. Now, ionic bond, on a scale of 0 to 100 scale...
Arbitrary scale.
Yeah, it's not
do
perfect.
not actually mean anything, but...
Yeah, it's actually, I made these up, Mr. Bergman. Sometimes called these Bergmanian scale of bond strength.
I like it.
So anyways, where 0 would be no bond at all. Okay, but ionic bonds are really strong, 85 out of 100.
Okay.
Metallic bonds are 65.
So strong, but not quite as.
Yeah.
Okay.
The strongest of all are the network solids, 100.
Okay.
They win the rule. Hydrogen bonds are 5. Ooh,
Okay.
big drop.
Yeah. Because those are intramolecular.
Yeah, these are
those are the intermolecular.
Inter down here.
And inters are always weaker
5.
than.
Dipole force, even weaker, a 1.
Yep. And then
And then the
LES.
London forces, really weak, a 0.1.
Okay.
So you get the idea is that we basically need to, we're going to look at some examples. The higher the number, the higher the bond strength.
And the higher the boiling point, and the higher
The
the melting point.
points.
Yep.
Okay, so let's just do some examples.
Okay,
So,
let's do NaCl versus H2O.
NaCl versus water. Okay.
Okay.
So for NaCl, the first thing I note here,
What kind of
this
compound
is
is
a
that?
metal bonded to a non-metal.
Okay. Ooh, that's an ionic.
So let's look at our
Compound.
chart here. Bonding,
Yep.
metal to non-metal. It's ionic,
And there's a number.
strength 85. So I'm going to write 85 next to
That's
NaCl.
easy. You just look it up. Ionic compound 85.
Way easy.
Okay, H2O.
Water. So let's go back on our chart and look up water. Now water is, oh actually, I need to,
Yep.
hydrogen is a non-metal.
Non-metal.
Don't get confused on water. Even though he's on the left side of the
He's
periodic
still
table,
non-metal.
he's a non-metal. So this is non-metal.
Okay.
So he's in the covalent,
category.
category.
Okay, so we go to covalent, and lo and behold, we have to decide: is
more
it
work.
polar, non-polar, or network? Well, I know it's not a network solid because it's not pure carbon and it doesn't have silicon in it.
Okay, so it can't be a network. So it's either
Okay.
polar or non-polar. So we have to now draw the Lewis structure.
Right.
So when we draw the Lewis structure, now Mr. Bergman's going to just draw it. You may need to, count out the number of
Right.
electrons and do the whole deal. So when we
Okay.
draw this, it turns out that it is bent.
Bent 104.5.
104.5.
And if you remember nothing from this class, remember that water is polar.
Yeah, it's polar.
Water
so he is polar.
Yes.
So if water is polar,
Now we go to the
we're
left.
over on the left column. Now it's
Okay.
either a hydrogen bond or a dipole force.
So
now water
it has hydrogen.
has hydrogen and it has O
Hey, look.
and H. Hydrogen bond.
So
He's held together by a hydrogen bond.
and hydrogen bonds have a value of 5.
5. Okay, now,
So
which
which
is
one's-
bigger, Mr. Sims, 85 or 5?
85 is bigger.
So
than
the
5.
one with the higher boiling point
Has a higher number.
Is-
Higher number has a higher boiling point.
is sodium chloride.
Okay.
That was easy. All right.
Yep. All right. Next, let's do iron.
Iron.
Versus CH4.
All right, iron.
Iron versus
Iron.
CH4.
It's a metal, right? So it's just,
Smackdown.
it's just like a metal. So if I go bonding and go to like metal to metal, that's like
65.
done. That's easy. Metals are easy. It's just like...
Iron 65.
You know, I'm an Iron Man, Mr. Sams.
Yes.
Yeah.
I have a shirt.
Yeah.
It has FE on it.
Yeah.
So I can wear that and now I'm Iron Man too.
Yeah, I don't think that's the same thing.
No.
Yeah.
Okay,
Yeah.
fine.
Okay.
right.
CH4. Now, C is a non-metal.
Mm-hmm.
H is a
Non-metal.
non to non. Okay, so
Okay.
we got to determine what kind of type this is. Now, it's non to non. We're going down the covalent middle column. So
Okay.
is it non-polar or polar? Now, wait.
Well,
Oh, there is carbon, but it's
but
not
it's
carbon
not pure
alone.
carbon.
So it's
not a network.
not a network cell.
And-
So it's either polar or non-polar.
So we got to draw it.
All right, so when I draw it, it's CH, H, H. It's a tetrahedral shape.
Yep. And they're all the same, so it's non-polar.
Yeah, this is a non-polar.
So,
if it's
non-polar.
non-polar,
LDF.
we go down to London dispersion force.
0.1.
He's a 0.1.
Mr. Bergman, which is bigger, 65 or 0.1?
I think Zeke could answer this question.
You know, he probably could, except I'm not sure he quite understands decimals yet.
Oh, yeah. Okay, well, anyways,
He would have got the last one. He knows that 85 is bigger than 5. for sure.
65 definitely wins. So iron would have a higher melting point than CH4. CH4, by the way, is natural gas that we burn. It's also produced in your body when you flatulate.
Flatulate.
So, and iron, you don't flatulate iron. That would hurt. that would
Thank
be-
you, Mr. Bergman. Okay.
What are we going to do next? Copper and diamond. right?
No. Graphite and HCl.
What am I writing here? Graphite and HCl.
Graphite, what is that?
Graphite is actually just carbon by
That's
itself.
just carbon. Right, we learned that in the last lesson.
Hey, carbon by itself. Carbon by itself. Network solids.
Network solid.
Hey! Oh, he's 100. You almost don't even need
Hey,
to
guess
do
what? That one wins.
this. He's 100. But just for the sake of argument, so
All
we
right.
can do this. HCl, this is a non-metal, and this is a non-metal. Okay, non-metal to non-metal.
Covalent compound.
Covalent compound. When you draw the Lewis structure, HCl, okay, and when you determine this side is negative and this side is positive, there is H right here.
Mm-hmm.
So maybe it's a hydrogen bond.
Maybe.
So we go polar molecule.
Okay. It has H, but
no
F's,
Cl is not
O's, or
F,
N's.
O, or
Nope.
N.
So therefore it is
it's a dipole.
Dipole.
So he wins. He has a big hole strength of 1. Obviously 100 is bigger than 1.
Obviously.
Graphite has a higher boiling point.
Okay.
Hey, let's do one more. Actually, instead of higher boiling point, we're going to rank them.
them.
So I've
All
got
right,
several
here we go.
of them.
I want copper.
Copper.
I want a diamond.
Diamond.
I want calcium chloride.
Calcium chloride is CaCl2, folks.
I want hydrobromic acid.
HBr.
I want ammonia.
NH3.
And I want carbon tetrachloride.
CCl4.
Okay.
So we're going to rank them from highest to lowest.
Right. First we need to go through and classify everyone then.
All right, so copper is just a metal.
That's just a metal. That's easy. That
When
one's
you
85.
just have a metal,
Oh,
it's
65.
a
Sorry, my mistake.
65.
My mistake.
Diamond, we've already
That's
kind of talked
pure
about
carbon.
it. So that's going to be the
Pure carbon is a
network
network solid. That's 100.
So this right here was our copper, and this is our diamond.
Okay.
So
that's
that's
100.
the 100.
CaCl2,
Calcium,
that's
a
a
metal
metal.
to a non-metal. So if we go back to our chart, metal to non-metal is
85.
85. So this is our CaCl2.
Okay.
So he's an 85. HBr.
That's non-metal, non-metal.
All right,
All the rest of those three are all non-metals.
These are all non-metals. I'm going to draw a Lewis structure. So I'm going to just draw the Lewis structures of
Okay.
each. HBr looks like this. NH3 looks like this.
Don't believe me? Add it up and do it yourself.
Yeah. Carbon tetrachloride looks like this. It's actually tetrahedron. I'm not drawing it very well. And then there's 6 electrons on each chlorine. Here, my tap, 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 tap. Okay.
Okay.
Now, HBr is a linear diatomic structure. And
Bromine
when
is
you
way more electronegative than hydrogen.
No, I think it's the reverse, mister.
Oh, is it?
Anyways, it's going to be polar.
Yep.
This down here is going to be a trigonal pyramidal or pyramidal shape, and it will be polar. And this one right here, because of the shape, is going to be nonpolar.
Okay, so the nonpolar is easy. That's an LDF. That's
So,
0.1.
Yeah, remember to go to, if it's nonpolar, it's LDF. So this is our CCl4. Now we've got to determine these two. We've given you one of each.
Right, in case you haven't figured it out.
Yeah, if you haven't figured that out. So which one has H in it?
They both do.
But this has N.
That's the N of phone home.
Phone.
So
Yep.
that's...
F-O-N.
So it's got N in
So
conjunction with
he
hydrogen. So
is
that
the
is
hydrogen
a hydrogen
bond.
bond. So that's a 5.
So he will be a 5. The HBr is going to be a 1 because that's the dipole force, and this is the 0.1.
All right, so let's go from
High to low.
High to low.
So the diamond
Didn't really
wins.
specify. And then CaCl2.
Would be greater than calcium chloride, which would be greater than copper, which would be greater than ammonia, because that's the hydrogen bond, right? Because this is the 100, this is the 85, this is the 65. Then we drop way down to 5, and then we go to HBr, which is a 1, and that's greater than poor little carbon tetrachloride, which is a 0.1. So it's just utilizing, ladies and gentlemen, this chart and being able to classify things, and then you can rank them very easily.
The end.
That's the end of this unit, the bonding unit. So, wow, we finished. See you in class or on the internet. Bye.